right. Hello, everyone, and welcome to this week's Digital Manufacturing Talk. My name is Tyler Fenhouse. I'm the marketing manager for Symphony AI Industrial, and we've got a great informational talk lined up for you today, labeled Building and Deploying AI-Based Multivariate Models. And yes, we are going to get underway here. As you may know, Symphony AI Industrial is a leader in industrial AI solutions and digital manufacturing, plant performance optimization, and connected worker. Symphony AI Industrial is a Symphony AI vertical. There are several Symphony AI verticals. You can see them there on your screen once Pujan pans to the next slide. And we are one of the largest, if not the largest, enterprise AI companies with more than 1,600 customers and 3,000 employees. We are on the Teams format this morning, and we've got a lot of people on this webinar. So you'll be silenced throughout the webinar, but we still want your questions. In the chat, you can type in any of the questions you want to ask our presenter today, Pujan, and he will answer them live right here after the presentation. So make sure you're typing those in as we go along. Also, be on the lookout for poll questions that we have for you, which will kind of guide Pujan's presentation today. So that being said, he's got a lot to cover, and you didn't sign up for this talk to listen to me ramble all day. So I'm going to hand it off to Pujan, and we're going to get this talk started. Pujan, take it away.
Super. Thank you, Tyler. Really appreciate that. And good morning, everyone. Good evening, wherever in the world you are. Very glad you could join us for the talk today and the webinar on building and deploying AI-based multivariate models. So before we get started and jump right into the material, I think it's obviously important just to introduce myself. So I am Pujan Ghelani. I'm a senior product manager here at Symphony AI. Got a background in industrial IoT systems across several domains, as well as a background in manufacturing engineering, supply chain, process improvement, Lean Six Sigma, etc. And I've worked across the US and in India at a couple of different companies. So very, very excited to be here and hopefully going to give you some things to think about with how you can build and deploy multivariate models. All right, so now that I've introduced myself, I think it would be great if I could get to know a little bit more about each of you. So Tyler, if we could have poll question number 1, please.
Yes, all right. So if you can just take a look, it's a radio button, just click to vote. Which one of these best describes your current roles? Data scientist, subject matter expert, domain expert, software engineer, manager, consultant, or other. So go ahead and click to vote. Looks like about half the room has voted. So go ahead and get those in. I'll leave this open for a couple more seconds. And again, this will kind of guide Pujan's presentation. So couple more seconds for everyone to get their responses in. All right, so it's looking like 21% of the room is data scientists, 14% subject matter experts, 21% consultant, 7% software engineer, 14% manager, and 21% other. Pretty split. Back to you, Pujan.
Super. Hey, that's a nice broad range of experiences and backgrounds. All right, so now we'll start to get into the topic. Now that I've understood a little bit more about each of you, again, just to start with a quick poll question, again, just to understand things a little bit more. So Tyler, if you could help with poll question number 2.
All right. Two right out the gate. How much experience do you have with AI model building and deployment? Never built an AI model. I'm aware of how to build a model, but never have built one. You built a few AI models, but never deployed anything to production. I have built a few AI models and deployed to production, or I build and deploy AI models frequently. So go ahead and get those in. Looks like half the room is voted. I will leave this open for 5 more seconds, so go ahead and click to vote. We appreciate your participation. Looks like everyone is pretty active today. All right, so 73% never built an AI model, 13% am aware, 13% have built a few AI models but never deployed to production, and that's all the responses. So back to you.
Right. Perfect. No, thank you, Tyler. So it's actually, uh, we generally get a pretty even split across some of the different options, but it's really glad that you're able to share some of this background in terms of having built an AI model. I know almost everyone has, at least that's voted, has not really deployed to production. So again, hopefully we'll make this informative. Hopefully you'll be able to learn a little bit more about building models, but then also building it using a no-code, easy to use UI as well, right? So we'll start with few bits of information really to introduce uh, the concept that we have here and really what goes into building an AI model. Of course, I'd like to continue that with a demo, so I will leave some time for it. But again, we won't spend too much time on the slides. It's really just to help set some context. All right, so typically a day in the life of folks in the production environment on a manufacturing floor. Typically, you have some variant of safety, quality, delivery costs, people metrics. You have certain equipment metrics and parameters that you're monitoring, whether it's production data or process data. Of course, at times you'd have quality data. You'd be analyzing maintenance records, and really you're trying to make use of this discrete data, discrete reports that you have, but really having a team come together to make decisions collectively based on their shared experiences and their shared skill sets as well. Now, it could again be asset data, quality data, etc. But again, wide variety, typically coming together with one group or one audience. But really, what's happening today is because you've got the proliferation of IoT devices. You've got significant capabilities when it comes to storage and computing of data. Really, what's happened now is the a consolidated data fabric, right? Which means that we're able to now pull in and consolidate data from different sources, whether it's asset data, things like operating parameters, pressure, RPM, for example, quality data, which could be yield or scrap, or process data, things like temperatures and flows, or even maintenance logs, right? So again, we're able to now consolidate each of the different data types from the different data sources that we do have available and we are interacting with. Now, typically, it starts, at least in today's environment, it's really relevant and extremely valuable to actually start by building a digital twin of an asset or a process. And really, the reason to do that, right, is to actually represent the physical conditions of your environment, your production floor, to essentially make smarter, informed decisions based on prescriptive, unbiased recommendations. And this, of course, could be used to build multivariate models, forecasting models, and a variety of other types of AI models using different fault modes, using causes, using recommendations, but really that context that you would like in your manufacturing environment, given your process and given your equipment. All right, so with the AI model building process, right? And we'll take a look at just some of the steps that are involved with it. Hopefully, it should be a good primer to folks in terms of what typically goes into it as well. And in general, it's a fairly linear process. So at least I'll try to explain it in a linear way. There are several iterations that you would go through, but it typically starts with building the asset model, right? And defining what the physical dynamics are in terms of the asset. So what is the nameplate, the nameplate details, the rating, for example. Then importantly, what are the tags that you're actually currently monitoring using sensors, using other instrumentation techniques on the equipment. Of course, in this case, and in some cases, you would also have expressions to calculate or estimate certain values which are perhaps difficult to measure, or difficult to actually provide and store as well. So again, you'd be able to create an asset model first, which really again is the basis of you being able to create and build that digital twin. So once you've actually built a digital representation of your asset, really what you would then want to do is start to connect to the data sources, wherein your instrumentation data for that or those equipment is actually being stored and being saved. This, of course, is to provide better context to the asset model that you've built itself. And then importantly, it's to actually help provide you with that digital representation of how your asset is performing. So in a simple case, for example, you may want to measure or monitor, how the temperatures are performing, or, the inlet outlet pressure, for example, might be, right? So again, that is simply what we're, talking about really when it comes to data connectivity. And then really we start to walk through the AI model building process, right? Or an analytic building process. Now, this typically is broken up into significant, into several different sub-steps, which I will come to a little later on today. But essentially, what we're trying to do in these steps is to build a model. So the first thing that we'd want to do is really go through exploratory data analysis, which is to clean the data, impute that data. Perhaps there are certain missing values or undefined values that need to be excluded or handled in a certain way. And again, creating a standard method of actually handling those data types and those data sets is what we would be doing here. Of course, then we would go through and train a model. And once we're happy with the model that we've actually trained, based on the testing data that we've provided it, based on, let's say, the alerts we might generate or the issues it might identify, we will then go ahead and actually deploy it to production. All right. And again, like I mentioned, I will come back to these two. So we will dig into a little bit more detail in the next couple of slides on this. But really, once you've got your AI model built, you've got it trained, you've got it ready. And this, again, would be an iterative process where there could be several models with sometimes minor, sometimes significant tweaks to the parameters, to the data sets, to the pre-processing steps you might have defined. But once again, you've gone through that iterative process, you would be able to and ready to deploy that analytic or that model to production. And then, of course, you typically end or continue on with building on the UI with how you want to represent the output of these AI models on a user interface on the application. Perhaps there are certain visualizations you may want. Perhaps there is certain alerts that you might want to configure. Role-based access as well could be configured as well. And then, of course, you would have insights and monitoring into how not just the analytic itself is performing, but then importantly, how your process or your asset and really your operation is performing as well, right? So now that you've hopefully understood the broader steps that are involved in the typical workflow for building an asset and AI model, what typically happens, right, is uh, given the several different steps that do exist, there are several dependencies, of course, on different functions or different groups of people across the organization. And obviously, there is a certain sequence that it does go through. There is iterations that you would need to go through as well. So while in a flow it looks linear, it's functionally very different. Now, typically you would work with subject matter experts for better context, for getting that domain expertise in how the environment or how the product itself is meant and designed to be built, produced, manufactured. There would be folks that are involved from a data science standpoint to really help with the statistical and programming skills to actually build out that model, perhaps iterate on it, tweak it to a point which is good enough to actually deploy to production. Wherein, of course, then you would have the DevOps teams or IT teams to really help manage, maintain these deployments to ensure reliability and stability of not just the application, but the models as well. So clearly, there are key distinct functions that are that are involved with the model building and deployment process, which means that there are several different, or several points at which it could fail, or really there could be lags in the process as well, right? Now, to really address this, we've got a digital twin studio, which is a no-code self-service AI model building environment to really transfer that power across different user roles. So you could be a subject matter expert, you could be a data scientist, or really someone who has some of the skills that are required for each of those two roles. But really, it's designed and built to enable model building, AI model building, through a very easy to use no code UI. And really, this is done to democratize the building process as well, right? All right, so now that we've covered this, would like to go into poll question number three, just to understand what some of your experiences are or your goals are with model building.
All right, and you can select all that apply. So today, which of these focus areas for your organization or your work, homogenization or standardization of data sources, connecting or extracting data from your data sources, AI model building, deployment or management, dashboard or UI configuration and management, monitoring operations and driving performance improvement, or other focus areas. So again, you can select all that apply. Go ahead and get those in. Looks like about half the room has responded. I'll leave this open for a little longer so we can get a better idea of what everybody is focusing on. So go ahead and get those in. Leave it open for a couple more seconds. Appreciate your participation. All right, so if we take a look, it looks like 12% homogenization, 29% AI model building, deployment or management, 6% dashboarding and UI configuration, 18% connecting and extracting data from data sources, 26% monitoring operations and driving performance improvement, and 9% other focus areas. Back to you, Pujan.
Great. So really, as I look through some of the responses, the top two is really the objective for this webinar, of course, but really why we're all here, right? Which is how do we use and deploy AI models to actually improve the monitoring of operations and driving those improvements that we're searching for. And so really what we'll do is, again, as we go through the demo, I will try to talk about how those models are built and how, again, it's going to impact your operations as well. But before that, I know I told you that I would get into these two steps specifically just to give a little bit more clarity on it. And so that's what we'll do, right? So really, the objective, at least for today, is to focus on the analytic build and deployment process. Keep in mind, of course, that we have covered other parts of this overall flow using our no-code environment. And so you'd be able to find some of these links up on YouTube, or feel free to reach out to us at any point in time, and we'd be more than happy to share more information. Right, but coming back to specifically what we have in analytic building and deployment. And really in this, it starts, if you think of it as a sub-process, really, starts really with the availability of data, which means that you really need to start with data that you do have for the equipment or for the process, that really does allow you to understand and hopefully really build a model around it in terms of understanding seasonalities, understanding variations, by busy periods versus light periods for or for your business and your operations as well, right? So once you've actually had the ability to collect this data, you then really go through that pre-processing step, and this pre-processing is, like I mentioned, uh, you know distinct steps that you would want to take to improve or really massage that data, if you will, which means that you would be able to impute certain values. You can, let's say, remove certain outliers from it by visualizing it, to really make sure that the data set that you are going to be working with is suitable enough to actually build a model around, right? Which again means that you want to be able to capture some of the variations, the trends, the differences really in how the operation is running over time. And really, you would start by splitting that data up into one set, which would be used for model training, wherein again you're going to actually again build a model, add in certain parameters for or how you want to configure the model itself, what type of algorithms you would want to use, and really use that data to build a model, which you would then test using another carved out portion of that original data set to actually go through with the model testing process as well. And this, of course, is really just to help with understanding how effective that model was in identifying, let's say, the faults or the issues or really the objective that you're trying to achieve through the model that you built as well. And so really these two steps are typically pretty iterative. You would also perhaps include the data pre-processing. Maybe you want to pre-process your data in different ways. But again, you would actually go through that, or you could go through that in several different iterations. And of course, once you're happy, once you're satisfied with the results, you would then be able to deploy that model. And essentially, what I mean by that is deploying the code or the source code for that model along with additional algorithms that would be required to actually successfully run the model in a production environment, which simply means that when you do have a live data pipeline coming in from your assets or your historian into the platform, the model would effectively run and then provide the output, whether again it be false or so on and so forth, on the user interface that you have designed and deployed this to. All right, so with that, let me just switch gears a little bit and we will go into the demo. And we'll try to take a look a little bit more at the Digital Twin Studio and some of the capabilities along the way, right? So let me just switch this. All right, go ahead and refresh just to make sure I'm still logged in. All right, so what you're going to see on the screen here is a environment that we've got for the Digital Twin Studio. Now, keep in mind that the Digital Twin Studio is actually a part of the user portal. It does have access control, so it is limited to specific users that you may actually choose. But importantly, it's really a part of the user portal, right? Which means that your teams, your audiences, your right folks can actually use this and very quickly and easily view or verify how the model is behaving in terms of visualizations, etc., in the user portal on a live environment as well. But really, in the digital twin studio, it's built to provide, if you think back to our workflow, provide an environment to really help with the asset model definition, to help you with data connectivity, and then the analytic build and deployment process as well. And so really, you've got several options here for it in terms of building the asset model and then connecting to your data sources, but really outside the scope of today. And so today, what I really want to focus on is the analytic model building process. And that's where we have the AI Studio. Now, typically in the AI Studio, you have a few different use cases or purposes that you can actually work with over here. So we have something called projects, and an AI project is essentially a logical grouping for you to have all of the models that you want to build for, let's say, the same asset or a similar asset, given the data set, given the pre-processing steps that you might want to do. Again, so it's just a way of how you can categorize or really organize your model building process in terms of the experiments that you would be running to iterate along with the different runs or the model runs that you would have to build these different models as well. Then, of course, we have data sets wherein you can actually import data from the platform. So let me just go into this. You can import data from the platform. Let's say you've already deployed it. You have data that you have available and you'd like to use that, or you can import data as a file. You can view some of the analytics that are available already, right? So you could have some models that you build, certain inputs, certain outputs as well. And then, of course, we've got FMEAs. Now, a failure modes and effects analysis template is essentially what provides the context to the AI model based on your production process, your assets, and your equipments and your know-how, right? Now, the FMEA is quite typical in the manufacturing environment, and it's again quite similar to how it's built here. You have the causes and failure modes really categorized and quantified with a risk priority number along with other aspects. You can also look at the different types of tags that you would be using or would want to use when you're building the model. And then, of course, you've got certain causes, recommendations, and then how you can actually weigh this as well in terms of how you can tweak the FMEA to really provide that context in a way that makes the most sense to you. So really, in this case, it's trying to provide a machine reasoning addition to the machine learning process that an AI model does provide. All right, so let me first start with ingesting some data, and I'll upload a data set just so we can get started into really taking steps to understanding how that model is built as well, right? So I have two data sets. I will show you what this data looks like. I'm just going to upload it for now. But again, I will show you, we will explore it, we will visualize it, and we will take a look at it just so you have a better idea of it. So I'll say DTS webinar August 23. And again, I've just imported a training data set, which you will see right here. Let's go ahead and actually view what this data set looks like. And so really this is how the data looks. So you've got time series data for several different columns or features within this. Each feature, of course, has a data point. In some cases, of course, you can see that there is some data that could be missing. Perhaps it's close to zero values, etc. But really, you've got one data set that you do have available. Now, really, what you can do is view some statistical summary information. So things like mean, median, mode, your min, max, etc. as well, right? So really, in this case, you see that we have about 1,000 rows of data in this data set. And then really you can start to visualize it as well. So what we'll do is we will just go ahead and select a few, let's say 6, right? We got these line charts. So you can again view how this data is actually trending, right? You can actually view it in a single chart as well to again understand how certain tags or features are actually behaving, versus some of the others. You have histograms that you can do to really understand the distribution in terms of what the skew perhaps might be and how you may want to handle it when it comes to pre-processing. You can also very easily and quickly look at the correlations, of course, being -1 to 1 that you can look at in terms of the negative to the positive correlations. And then, of course, you can understand the outliers as well. So again, in this case, you can see that this feature has several outliers versus some of the others just has a much wider range versus some that do have a smaller range as well. So really neat tool, neat visualization option that you do have, and you can actually go ahead and just add in as many as you'd like, to really help you visualize some of that data, right? So that was one of the data sets. Like I mentioned earlier as well, what we're really always looking to do is create a training data set and a testing data set. Now, the training data set is what we're going to use to actually build the model. The test data set or the scoring data set is what we will use to actually verify how the model is actually performing based on information that we have, right? Just to again ensure that the model is providing a output which is in line with what our expectations are as well. So I'll go back into the statistics, so the summary statistics. So in here you can see that we've got 500 rows of data, which means we've got a smaller data set in here, because if you look back, each row was a single timestamp of data. And so you've got 500 rows of data that we're actually going to test our model that we build on as well. All right, so let's do this. We'll go ahead and create a new project. We'll say today we're doing the DTS webinar. Oops. We go in August. And same thing there, and we go ahead and create a project. Now, we go ahead and look at this project itself. And like I mentioned, this project is a logical grouping for how you may want to manage your experiments. So in this case, we'll say this is a ball mill anomaly detection model that we're going to try to build. Anomaly detection is the first one that we're going to try to build as well. And so really that's where we have this grouping of experiments, right? Now within one experiment, which in this case is the ball mill anomaly detection, the first thing, of course, that I would want to do is actually select the FMEA rule set. So, right, this was one of the templates that we do have available. But of course, you can always add in your own. You can configure or customize the FMEA as well to actually tweak it and then have it available for you to use as part of this digital twin studio. Now, the training data set, and that's the first one that we will use. Right, this was the first one. That's the training data set. Uh, this is the same input features that we saw. So it was the same, I believe, 14 features that we did have, along with a scoring or a testing data set as well, right? So we go ahead and upload that. And right, so this is really how it looks. We've got the same set of features. We've now configured what we would like to use for this experiment. Now, really in this next step, right, what we're going to do is what we call creating a model run. Now, in a model run, you can have several model runs that you may want, and you can actually do this in two different ways. Now, we look at the first step, which is a little more, I would say, manual in nature, or single or singular. But then, of course, I will show you how to create a model very simply, just using a configuration file as well. All right, so in this case, we've got this model, and really the first step, again, going back to the workflows that we just saw, the steps that we just walked through, that first step, once you have data availability, is in pre-processing the data as well. You can choose to skip pre-processing. I don't want to do that, but we are going to, again, pre-process this data, right? So again, in this case, what I can do is just go ahead and at least visually show you what this pre-processing data looks like based on the certain settings that I do have here. But again, I will tweak this around, and we can then take a look and see how this data set actually looks once it's been pre-processed. So these are the different columns that we do have available, and you'd have your visualization options. So again, in this case, there is just a little bit of pre-processing. So right, up front, really no difference in the raw versus pre-processed, because we've not selected to impute any missing data. We've not decided to remove any outliers. So essentially, the data is as is. As we were looking through the data set, we didn't see any missing values either. And so again, it's not actually dropped any rows or columns. So again, no change really to the raw and pre-processed data that you do see here. However, though, of course, you could choose so you could choose to impute certain data. Maybe you want to use, one of the outlier methods as well, if you'd like to. But again, I'm just gonna, just choose to impute data. But again, I'm quite sure there is no data to be imputed, because really all of that data does exist, right? And exactly, that's exactly what I expected as well, right? So again, this is the pre-processing step for your training data set. I am okay with this, and then I can go to the next step, which again, in this case, is going to help me or prompt me to configure what those parameters are, in terms of how I want to configure, or what algorithms I want to use. So you have several options in here. So you have the autoencoder. You can use your KNN, which is a K nearest neighbor method, or you can use, again, the PCA as well. You can actually configure this in a few different ways. At least this is what's available immediately in the UI as well for you to do. Then, of course, you'd go through pre-processing, and now this is going to be for the pre-processing data. Similar options that you do have here in terms of imputing data, removing outliers. Perhaps you want to select a shorter or a smaller time range. You could actually do that as well. But again, I'm not going to make any change to that. Really, I just want to see how the raw and pre-processed data looks, which again, in this case, I would suspect it to be the same. And that's exactly how it is as well, right? So this is really how the data looks. I am satisfied with it. I don't want to change too much. Really, in this case, I'm just trying to show you how the Digital Twin Studio is actually working in terms of the steps and the options you do have available. Now, when it comes to actually testing, right, or scoring, there are several parameters that you do have in terms of the output and how the output is going to be handled. Now, most typically, when with anomaly detection, you really would want to configure it for certain alerts that you may want to generate. And so really in this case, you're given several options to configure the alert parameters in this case. So for example, you could have a threshold that you could set for certain alert levels. Perhaps there is a silent period you may want to use. And again, in this case, if you're not sure, you can always hover over what that value is or what that actually means. And so you have those options. But really, you can configure how you would want your alerts to be generated as well. And so you can actually imagine where you have several tweaks that you may make to this. But once you're ready, once you've actually looked through the pre-processing steps for training as well as testing, you can come through and then actually say the ball mill anomaly detection run one. This is the first run that I am going to build, and I'll go ahead and actually run this, and I'll show you how it looks now. So while this is again going to go through the process of the model being trained, um, and then getting ready for it to be tested, we can actually just quickly view what the other option is that you do have in terms of viewing the configuration file as well. So let me show you what that looks like first. So I will show you what this file looks like. Oops. I will upload this first, and then I'll show you very quickly what the file looks like. And so you have the option again to actually download a sample file as well, but we'll go ahead and upload it. Right. So the file that I just uploaded, let me open that for you so you can take a look at it. Here are the different options that we do have that we've essentially just created and entered in using a YAML file. Now, this configuration file, for those folks that are a little more inclined to use, certain or more comfortable with code or with data science, they can simply create a file like this, make sure that they put in the values that they'd like to see for pre-processing for the training set, testing set as well as some of the parameters that you may want for training and testing. So very similar to what I just showed you when it came to training and testing as well. So you could actually upload that file, saves you the step of going through the UI if, again, you're more comfortable with it. But we'll go ahead and, right, so go ahead, run this as well, just so you can actually see how it is actually done. And great. So in this case, we have the first model which was run one, right, that we actually created, and we have that available. Now, in this case, you can actually view it. So that's exactly what we will do, or you can actually choose to duplicate it as well. And now the reason to do that is you can imagine between these two runs, I could have had different parameters that I may want or choose to have with training or testing that perhaps would have or could have been different options I may have wanted to use with pre-processing for the training and testing data set to really just tweak the model that I'm building slightly, just to compare it with that same data set and really understand what the differences are, right? So again, in this case, we'll take a look at the first model that we do have and that we have built. And let's see what that actually looks like. So we have one alert that was generated. In this case, we have the alert level that was generated. So again, if you think about the thresholds that we had set, there would be causes and recommendations. Again, this is what would be coming in from the FMEA as well. So you can always tweak that around. In this case, there wasn't anything that was identified, but then you get the contributing factors as well. And so really, in this case, you're able to very clearly tell that there are the top two tags that contribute the most to this specific alert and how they're actually trending over time as well. So you can actually view it to again verify that the result that you're seeing on this page is in line with what your expectation is with the model that you've built. And if it is able to detect those faults or those issues that did actually surface up during the time period when that training data set was collected as well. And so again, you do have the option to actually view this. I can always close out of this. Let's just make sure that we have the run available, right? So in this case, we have this run available to us as well. And let's see if this is any different, right? So we had the current and power. So again, very similar output. The only difference being, I believe, that this is just a slightly more higher contributors to this alert that we have as well. But again, we'll go back to the first run because really now what I'd like to do is show you what you can do next, right? So a couple of different options. You could either choose to retrain or retest this model, which means you could essentially go back and tweak the parameters that you've used. Let's say retrain, you could tweak the parameters you've used for pre-processing and training, or for training, testing, pre-processing and testing parameters as well. But again, in this case, I'm not going to do that. I'm going to assume this is exactly the model I want to use and that I actually want to deploy as well. Now, in this case, you have a couple of different options. Keep in mind, right, that when you're actually building a model for the first time, you would actually want to obviously create a new deployment for it, which means that you would actually want to make it live for the first time. Or going forward, when you're retraining and then retesting your data, perhaps you've got new data that you want to ingest and use to tweak the model. You could actually use the same model to replace an existing analytic as well. I could just very quickly show you what that looks like. So it's quite straightforward. You'd be able to, select, a model, and actually just choose to replace, choose to replace this specific deployment. But again, I'm not going to do that, because really what I want to show you is how you can actually use this to create a new model and then deploy it as well. Now, in this case, what you did see, hopefully in the loader text, was a really helpful feature, we believe, to help you with speeding through how you're able to deploy the model directly. Now, what it said is the automatic feature is actually trying to match the features that we have in the data set to an asset model that we've got, with certain tags or channels that we have defined as part of that asset as well, which means that the model is detecting that, hey, this is the model that you're trying to use with this specific asset. And I did recognize that you do have these three features from your data set matching exactly to a asset that you have, which in this case is ball mill, and the tag being ball power, right? So you do have three of these. So you do have three of these tags or interfaces which are actually mapping, which really form part of the input, which you could obviously go ahead and actually select it. So, for example, in this case, I do know that this is the. There we go. Just search for it. Yeah. So floating, right? So you do have, yeah, this is on, right? So yeah, so you'd be able to select essentially oops, I've mistyped there, but essentially you'd be able to choose the right channel to map to the input interface that you have used in this model specifically, right? Now, once you've actually done this mapping, you would also be able to select the unit family as well, right? So in this case, you can select the different. Sorry, there just seems to be a lag at my end. Apologies for it. But again, right, so you do have the ball mill asset that was identified. You have each of these individual channels that were made available. And then, of course, you've got the different unit families that you can use as well. And all of these are typically mapping to certain inputs of that model. Of course, you do want to map it to an output, which in this case, it's a single output that we're generating from the anomaly detection model, which in this case would be the anomaly score. And again, you would be able to map this or match this to a specific output channel for that specific asset as well. And then again, you could go ahead and actually use that at several different points, perhaps to calculate certain values, to provide alerts to you. Perhaps you want to use it to calculate a health score. Again, just different examples for how you may choose to use and use the output from a model that you have actually deployed. But once you've actually selected it, let's say I did have all of the inputs mapped out as well, I would then be able to go in and just put in certain parameters in terms of certain minimums or maximums and thresholds that I may want to have, and then ultimately verify it before I choose to deploy as well. I'm not going to go through each of those steps right now. I think it's fairly hopefully clear now that we've gone through with how the model's built in terms of pre-processing steps for training, as well as the parameters or algorithms you may want to use and the inputs you may want to give to that as well for training, as well as for testing as well. And then really once you've got or verified the results of each model that you build from each run, choosing that appropriate model that you want to use, and then ultimately deploying it in a very quick and easy way as well. So this is really how you can go through the model building process. again, hopefully it was clear enough to understand how you're starting off with importing your data sets, pre-process or building out or using the organizational structure that we do have of a project, experiment, and a run to then have multi-threaded runs that you could actually use and deploy to use and build as well, which off which you could then choose to deploy just one of them, right? All right, so that was really all for the demo that I had. Now that we've actually looked at it, I just want to maybe come back and just walk through some of the steps and recap on what we've seen, right? So coming back to hopefully what is now our familiar workflow that we do have, the Digital Twin Studio, outside and beyond of what we've seen today, really does help with building an asset model. So hopefully, not sure if you can see this, but really we've got the ability within Digital Twin Studio to actually import your tags from your equipments, build your assets with those nameplate configurations, what those specific parameters might be, or tags might be, or input channels might be. If perhaps there are certain calculations that you do require, you can actually configure that as well, which could be things like, arithmetic operators you may want to use, or, inequalities, perhaps even if-else statements, if you do have complex computations for things like, let's say, pump efficiency, right? So once you've actually got your asset model built, we have a library of data connectors that makes it available to connect to different data sources. So whether it's ODC, ODBC, OPC UA, DA, OSI Pi, etc., you're able to connect to each of these data sources to really make sure that the analytic building process when it comes to using data from the platform or data sets that you're just uploading, you actually have available to you as well. And then, of course, you have the now familiar, hopefully, AI Studio environment that you do have, wherein again, you have the data sets, you have FMEAs that you can configure. You can go through that grouping to build projects, experiments, and runs. You can view the results and then deploy the model that you do have. And then, of course, we've got a very easy to use configurable UI and dashboard builder as well, which helps you then set up the UI and set up the alerting and notification settings that you may want, for example, in addition to other monitoring tools that you may require when it comes to, let's say, a data pipeline as well. Right, so that is really all about Digital Twin Studio. Today, we've spent a lot more time focusing just on the analytic model building and deployment process. That really was the theme for today. Really would have been great to actually share a lot more with you that we have with Digital Twin Studio. But really looking forward to your questions and obviously hearing back from you. Perhaps a little later today or in the chat as well. So that's really all from me. Would really like to open it up to poll question number 4 to really hear from you now.
All right, fantastic presentation, Pujan. We do have one more poll question here until we start to answer your questions. Again, get those in the chat after you answer this quick poll question. Are any AI model building and deployment tools currently used in your organization? You have your own custom AI modeling, building, deployment toolkits. You use a combination of in-house and third-party tools. You exclusively use third-party tools. We engage in professionals to provide this to experts in our company, or not sure if any tools are used. Go ahead and get those in. And again, if you have not submitted any of your questions to Pujan in the chat, go ahead and do so. He will be answering those shortly after we get through with this poll question. I will leave it open for a couple more seconds. Looks like a good majority of you have responded. And then we will get to those. Actually, Pujan, I'm going to take control of the screen here for a second while we wait for people to get those questions in. All right, let's take a look at the responses. So it looks like 70%, the majority of the room is not sure what tools are used. 10%, they rely on professionals to provide those kind of services. And then another 10%, they use a combination of in-house tools and third-party, and 10%, they have their own custom AI models, building and deployment toolkits. Okay, that being said, a couple of people, Pujan, sent me directly. So it's not in the chat, but I will get to that in a second. But first, everybody, we really appreciate you attending our digital manufacturing talks. They've been a huge hit in various industries. But if you just take a look at your screen, we do have many other uh, digital manufacturing and connected worker talks in the pipeline, and they go all the way through into the end of November. And if you want to see what we have coming down the pipeline, we surely have subjects that pertain to your industry. All you need to do is go to symphonyindustrial.ai, go to resources, drop down to webinars, and you can see all the digital manufacturing talks we have in the pipeline, and you can register right there on the page. So again, we appreciate you showing up. Uh, they are very beneficial to various industries. So you're going to want to take a look and see what we have. We surely have something for you. All right, so let's take a look at the chats. Pujan, I'm not sure if you had a chance to look, but first let's get to some of these direct messages that I received. So first question, who has access to the Digital Twin Studio?
So the Digital Twin Studio is actually can be accessed by all users. Of course, we can have certain restrictions that you may want to put in place as well. And there is a role-based access control system that we do use. So you can actually decide who should have access, but those users have access directly from the user portal. Essentially, they would see an icon. Sorry, they would see the additional icon if they do have access to it, and that's really where they can enter Digital Twin Studio.
All right, fantastic. And then we did have a couple people asking for the recording of this session. I will have that up shortly after we close up shop here. I'll have a YouTube link. So anybody that requested that, I will definitely have someone from Pujan's team reach out and get you that link once it's up. All right, next question, Pujan. What are the different types of models which can be built using DTS?
Hey, that's an excellent question. So what we've seen today is just the anomaly detection model building process and how you can deploy it. Objective, of course, today was to help you understand the capabilities, but really how the model building and deployment process actually works. In a very similar manner, you're actually able to deploy models, uh, such as regression, classification, forecasting, optimization, and then sensor faults. So several different options available in how you may choose and which models you may choose to use and deploy as well.
All right. Let's do one more here. How long does it take to build and deploy models for production environments?
Right. So what we walked through today was a very simple case, right? It was a fairly small data set, I would say, just about 1,000 rows in the training data set, like we saw, and about I think 10 or 15 features that we did have. Now, obviously, in a production environment, typically your data sets would be a lot larger, and there would be several iterations you would have to go through before you're ready to choose or select that specific model to actually deploy. What we have observed is it takes anywhere from about 10 to 30 hours to build a single model, just given the iterations you do need to have, given the pre-processing steps you may need in addition to pre-processing the data as well. So that's the typical range, but again, it could be less than that. It could be greater than that. What I do know or what we do know in terms of feedback that we've heard from users is the Digital Twin Studio UI makes it very easy for folks that are not experts in data science or not experts on the domain side to really leverage the capabilities of the platform to build these AI models. And that means that you can do it through a UI through a few clicks. You can also use some of the templates that are available. If you choose to do so, you can also upload your own models as well. We saw the configuration file, so you can choose to do that as well. So really, it can be done in really any way that suits you and your skill sets the most.